So today we're going to multiply and divide rational expressions. And so again, remember that rational expressions are those like fractions that happen to have variables in the denominator. So here we have multiplying and dividing rational expressions. So just like we did when we were simplifying rational expressions, we need to start by factoring them. Okay, we have to factor each part first. And then when it comes time to multiplying it, we can cancel numerators and denominators that are common factors, that either have common factors within them or that are the same. In dividing, we first have to change, flip the fractions, turn it into a multiplication problem. Then we can worry about factoring it, and then we can worry about canceling and actually solving everything. So we're going to start just doing some problems. So when we get to the multiplication here, I know that when you multiply with fractions, one of your instincts is, hey, I'm just going to multiply across the top and across the bottom. But if you do that with this kind of problem, it's going to give you it's going to end up giving you a more complex problem, which is going to be quite difficult for you to simplify at the end. Let me give you an example. What if I have, the fraction, let's say 12 over 24 times 18 over 24, okay? And if I was to do what my instinct is and what I was initially taught to multiply across the top and across the bottom, I would have a pretty complex problem to solve here. I would get 18 times 12, and that would give me 216. And I would do 24 times 24, and I would get 576. And then I'd have to start the process of simplifying from there, which would take me a very long time. So what we learned when we did multiplication of fractions is we said, hey, if at any point you can simplify a fraction either from numerator to denominator, like 12 goes into 12 once, it goes into 24 2 times, or even denominator to numerator across, like 2 goes into 2 once, 2 goes into 18 9 times, and then 9 and 24 share a 3. And so I could do 3 goes in here 3 times, 3 goes into 24 8 times, and then what's left over, the 1 and the 3, 1 times 3 is 3, and 1 times 8 is 8. Notice that I never had to get to those ugly numbers of whatever, 216 and 576 or whatever. So canceling prior to multiplication is a great strategy, okay, or factoring or canceling common factors is a great strategy to make the things a little bit easier. So when you get to these multiplication problems, that's what you're going to do first, is you're going to start out by factoring. So factoring the numerator, x minus 2, it's already factored, right? The denominator on the left is already in its simplest form. We're going to take the x squared minus 9, and we're going to turn that into its simplest form. That's a difference of squares. That's x plus 3 times x minus 3. And then the denominator is x plus 4. And so what happens is when you see that when you do that, you start to be able to get rid of stuff. So we see there's an x plus 3 down here and an x plus 3 over there. Now we get x minus 2 times x minus 3 all over x plus 4. And so this is actually the product of this problem. This is the solution of this multiplication problem. And so what happens is a lot of you are going to ask, hey, do I have to FOIL the top? Do I have to make that, x squared and do all that? No, you do not. In fact, we don't want you to. We want the numerator in its most simplest form. We want it factored like that. We want the denominator simple because that way we know, hey, it's fully simplified. There's nothing else that can be done here. And so we actually like it left like that. And again, when you have to do other things with it, like sometimes, eventually you might have to add or subtract, we want it broken down into these terms. So you don't have to go any further, and that's the answer. So again, we're going to keep going, and we're going to keep doing these. We get here, again, the numerator on the left is a difference of squares. It's actually x plus 3 times x minus 3. The denominator on the left is fully simplified. It's x plus 3. On the right, we have x plus 4. And in the denominator spot, we have x minus 3. And so everything here is now fully broken down, and we can just start canceling. So x plus 3 and x plus 3 cancel. X minus 3 and x minus 3 cancel. And we're left with x plus 4 as our final answer. And that's it. That's the answer. That's the product. If you were to actually multiply this expression times this expression and put it over this one times this one, and then try to cancel out the common terms by factoring that nasty thing at the end and canceling, you'd get down to the same thing. But obviously, this is much easier. So we factor so that we can cancel. Again, here's another multiplication problem. Notice we have trinomials and binomials and whatever. So we're going to do each one. So I'm going to do it right underneath it. So this first trinomial at the top, 2x squared plus x, 2x squared plus x minus 6. To factor that, I need a product of -12 and a sum of 1. So I know that's plus 4 minus 3. So again, when I factor this, I do 2x squared plus 4x minus 3x minus 6. I take the GCF of the first two terms, and I get x plus 2. I take the GCF of the second, and I get x plus 2. X plus 2 is my new GCF, and 2x minus 3 is what's left over, right? So x plus 2 and 2x minus 3. Then I go to the denominator. The denominator is much easier to factor because a is equal to 1. This is just an x plus 5 and an x minus 1. I go to the left one. Now notice that this is cubed, right? There's a GCF there. So I'm going to take this x cubed minus 3x squared plus 2x. I'm going to factor out the GCF. I'm going to get x squared minus 3x plus 2. And then I can factor this trinomial, which is going to be x minus 2 and x minus 1. So x times x minus 2 times x minus 1. And then this denominator here is a binomial, so I'm just going to factor out the GCF. Oops, not 4x. The GCF is actually 2x. And I'm going to be left with 2x minus 3. And so now that I have it like this, I'm ready to start going through and canceling out my common things. So let me just kind of erase that and give myself some space, right? So again, I've got a 2x minus 3 and a 2x minus 3. I have an x minus 1 and an x minus 1. I have an x and that x down there. So if I'm looking at this correctly, I see that I have an x plus 2 left over in the left, an x minus 2 left over on the right, and an x plus 5 at the bottom, and a 2. So that 2, I kind of like to put it in the front, so it could be like that. And so that is the final answer to that problem. Now, again, you cannot cancel things that are in the same level. Like you can't cancel two numerators, you can't cancel two denominators. You have to cancel a denominator with a numerator. But that is the final answer to that problem. We keep going, we get to the next one, and again, we're going to go, obviously the first fraction is fully simplified, nothing to do there. The second one is actually the second one's fully simplified too, so really it's nothing to do there. I just have to look at it, and I know that x plus 1 and x minus 1 and x minus 1 are going to cancel, and I know that 5 is divisible by 5 one time, and 25 is divisible by 5 times. So my answer is going to be 1 over 5 times x minus 2. And that's the answer there. So we just keep going, doing the same step every time. We're going to basically factor our trinomials first. So the top trinomial here is going to be x minus 3 times x plus 2. My denominator is going to be x plus 3 times x plus 3. On the right side, it's going to be x plus 3, and the denominator on the right is a difference of squares. It's x minus 2 and x plus 2. And so now I've broken them all into their factors, and again, I'm ready to start canceling. So x plus 2 and x plus 2 cancel. X plus 3 and x plus 3 cancel. And I think that's all of it. So x minus 3 at the top, and then the bottom is going to be x plus 3 times x minus 2. And that's my final answer. So keep going. Now again here, you got to remember, notice you've got this x cubed minus 8 here. And this is the one that we did before. We did them with a u. Remember when we did u cubed minus v cubed? or we know it as a cubed minus b cubed. Same idea. If the first number has a cube root, and this one does, it's x. If the second one has a cube root, which this one does, it's a 2. And because it's a minus, it's called your difference of cubes. And the formula is that you're going to do u minus v times u squared plus uv plus b squared. And if we choose to use the a's, it's the same thing. A minus b, a squared plus ab plus b squared. And so same goes for this one. So because my, first term is the cube root is x and the cube root here is 2, it's going to be x minus 2 times x squared plus 2x plus 4. So that's that one factored. My denominator is a difference of squares, so it's x minus 2 times x plus 2. When I go to the right side, and notice this is a division problem. So let me just write it as a division. I'll flip it after, okay? My numerator is going to be, notice my numerator is x squared plus 2x plus 4. Well, that's unfactorable. I can't change that. And my denominator, again, is going to be that situation, but it's going to be a sum of cubes. So instead of this minus, it's a sum. Well, the sum of cubes, the formula for that was u plus v times u squared, right? U squared minus uv plus v squared. Okay, so now I do that formula. So this one's going to be x plus 2 and times x squared minus 2x plus 4. Okay, so now I have it factored. So what I did was I factored first, but now I have to remember that after I factor, I have to flip it. So the whole flipping thing's, kind of a little bit of a pain, but I got stay. So the first fraction stays exactly the same as it was. Okay, that does not change. So I've got x plus 2. Then I change it to multiplication, and I flip it. So this is x plus 2 over x squared minus 2x plus 4. And my denominator becomes what was my numerator. So the stay, change, and flip. Now that you have everything the way it needs to be, now you can start to do your canceling, which I think is the fun part of all this. You got an x minus 2, x minus 2. You have an x plus 2, x plus 2. An x squared plus 2x plus 4, x squared plus 2x plus 4. And then notice you're just left with x squared minus 2x plus 4 in the numerator spot, and that's your answer. So it's actually, I think it's a fun process. I like doing it. Again, the factoring is the trickiest part, especially when you get the difference of cubes or sum of cubes is remembering those formulas. But once you lay it all out and you put it in all its pieces, it's just canceling common factors and writing out what's left. Again, here we'll do our last couple, right? So we're going to do stay. So we'll do the, stay, change, flip, whatever. But first, let's at least factor what we have, right? So let's factor what we've got. We've got an x cubed minus 1. So this is a difference of cubes. And so this is going to expand out to x minus 1. And then it's going to be x squared minus x plus 1 is going to be, or plus x, sorry. That's going to be your factors there. Your denominator is, you have x squared minus 1, which is a difference of squares. So that's x minus 1 times x plus 1. And then again, keep it as a division problem for now. And you're going to factor your numerator, which is x. Oh, the numerator actually is not factorable. So the numerator is going to stay x squared plus x plus 1. And then your denominator is going to be factorable. It's x plus 1 times x plus 1. So now I'm going to get ready and I'm going to do my stay, change, flip, right? So I've got x minus 1 times x squared plus x plus 1 over x minus 1, x plus 1, times, that's my change my sign, and flip my fraction, x plus 1, x plus 1. And then I have x squared plus x plus 1. And so now I'm ready to just start the canceling process, which again I think is the fun part. So x minus 1, x minus 1, x plus 1, x plus 1, x squared plus x plus 1 right there. And notice that you're left with just x plus 1. So your solution to this problem is x plus 1. And that's it. And then we go to a couple more. Now, some of you guys might say, well, why do you have to keep it as a division when you factor it and then flip it after? Well, you might not realize why I do that now, because we're not asking you domain questions right now. However, this is all affected by the domain. Remember, we talked about that when you have a variable in the denominator, there's certain restrictions to that variable. And so you're going to need to look at the denominators from the original problem, and then you're going to have to look at the denominator when you flip it, and all that's going to go into account to find domain. So we're not doing it right now in this section, but just that's why I factor it first as a division problem, then I change it to multiplication and flip it, and then I actually do my canceling. So there is a reason why I do all that extra writing. It's not just because I like to write extra stuff. Again, we go here to this number 8, and notice that the first fraction is completely already simplified. The second one, that's going to stay the same, but the denominator is x plus 1, x minus 1. It's a difference of squares. Then I'm going to do my stay, my change, and my flip. And then I'm ready to cancel my common things, x minus 1, x minus 1. Notice I have an x up top and an x squared at the bottom, so I'm going to have an extra x left over at the bottom. So I'm going to have x plus 1 over x, and we already talked about it. X plus 1 is a group. I can't just cancel the x's. So the final answer is x plus 1 over x. And last one, again, lots of things thrown in here. Let's first factor the numerator on the left. That's going to be x minus 7 times x minus 7. Notice the denominator is a difference of squares, so it's x minus 7 times x plus 7 divided by. And then again, I'm going to factor out a GCF, so that's going to be 3 times x minus 7 all over x plus 7. So I left it as it was as a division. I factored everything. From this point now, I'm ready to do my stay, change, flip. So again, the fraction on the left is, let me just kind of rewrite it, x minus 7, x plus 7, change it to multiplication, flip the fraction on the right, 3 times x minus 7. And now that I did my stay, change, flip, I'm now ready. Now that it's a multiplication question, I'm now ready to cancel. So x minus 7 and x minus 7, another x minus 7 and x minus 7, x plus 7 and x plus 7. And notice that I'm left with nothing on the top, which is just 1, and a 3 at the bottom. And so my answer is 1/3. And so again, you're not multiplying this crazy trinomial times this binomial and coming up with these higher degree polynomials. That's just extra work, and it's inefficient, and it really isn't going to work well. So what you're doing is you're factoring, you're breaking it down to its most simple factors, canceling things out, and then whatever's left over, you're just going to list it. Everything left over on the top gets listed as a series of factors. Everything on the bottom gets listed, and that's your final answer. We do not expect you to take that final answer and multiply and FOIL everything that's left over. You leave it as a set of factors.